You have created your automation project in the Concept and Design tool, CDT for short, and configured the required number of input and output signals, as well as the devices. In this case, the signals and devices were automatically distributed evenly to the control cabinets, the 4 remote stations, as well as the 5 automation systems. In this use case, you will learn how to redistribute the signals and devices to different automation systems on a project-specific basis. To do this, first click on the tab Details per AS Remote Location on the left. The overview of all automation systems with the assigned number of signals and devices is displayed. Adjust the values in each DI, DO, AI, and AO fields of the decentralized periphery. An under or exceedance of the pre-entered total number is shown in color. After this, you must confirm the changes. By confirming, the expert mode will be activated. The transfer of the change distribution automatically performs recalculations, for example for a CPU calculation or BOM. We now switch via the tab to the Overview page. The padlock symbol on the decentralized periphery indicates that the distribution was done individually by the user and not automatically by the CDT. The activated expert mode is also visible in this view. From this point on, you will no longer be able to make changes at this level that will influence the number of input and output signals. Only on elements that do not yet have a log as a marker are changes possible, which are distributed evenly again. Now we switch back to the tab Details per AS Remote Location. Redistribute the Profibus PA and DP devices here and then confirm the adjustments. We now switch again to the Overview page. We see that this periphery is also marked with a padlock for the respective field buses, and this means the number of devices is also logged. In the next scenario, we adjust the distribution of peripheral signals and devices in the inside the building level. To do this, we switch back to the tab Details per AS Remote Location and select the level inside the building. Redistribute the signals of the distributed I/O as well as the I/O for Profibus PA and DP devices and confirm all changes. By switching back to the Overview page, we see that the number of complete devices on the corresponding peripherals can no longer be changed. In the next scenario, we exceed the allowed number of input-output signals on an automation system. To do this, we switch to the Details per AS Remote Location and increase the number of DI/DO signals on an automation system without adapting the existing distribution. This exceedance is visualized accordingly in the respective lines. We accept the change and receive the notification that the automation system has been exceeded or overloaded. Via the exclamation mark on the automation system, we receive detailed information on the CPU calculation. In our scenario, the maximum cycle time and number of process objects were exceeded. Based on the store configuration, you can see which specific characteristic values and exceedances have been calculated for this CPU in the CDT. In order to cover this higher demand for signals, an additional automation system is required. Since we are in expert mode, the additional automation system is not added automatically, but manually by the user via the plus icon. In the next step, the signals and devices are distributed to the additional automation system and thus receive an individual configuration with sufficient reserves. Of course, we can deactivate the expert mode. However, this means that we lose all previous changes and the signals and devices are distributed evenly across all automation systems. In this use case, you have learned from practical examples how to distribute your signals and devices individually via the automation systems using the Concept and Design tool in Expert mode. With the Concept and Design tool, your process control system architecture is perfectly designed.